Okay, here is the graph of a function y equal to f of x. The question is, we want to know if the limit as x approaches 2 for the function exists or doesn't exist. Now, because of this is a discontinuous graph or function, the graph, we have to approach the limit from two different directions, and if the two limits are the same, then the limit for the function as it approaches 2 then exists. If it doesn't, they don't match, then it does not exist. So let's go through. First, part A right here, limit of f of x. We want to find if x approaches 2 from the negative side. So this part right here, the symbol here, that means approaching 2 but coming from the negative, so that means from the left hand side. So in this case, what we want, we're coming this way. So we are using all the values of x. So as it's coming through from the left to 2, we notice that the value of f of x will end up being 3, which is right here. Okay, so that's as close as it can be, and that's very simple. Then we're going to use the right hand side, because it says find the limit as x approaches 2 from the positive side. So here it is, positive side. So this is from the right side coming, approaching 2 for the function. We want to know what how that works. So we're coming this way now as is approaching 2. Notice that the value of the function, the limit becomes 1. Now notice that 3 and 1, they're not the same. They're not approaching the same value. And because of that, we conclude that this limit right here, the limit of the function f of x as x approaches 2 doesn't exist. Very simple. The two values are not the same. If they were the same, if the left limit was equal to the right limit, the value of each of those limits, and then we would say that the value, the limit does exist, and there would be a specific number, but in this case it does not. Excellent. Okay, let's do another question. So we have this function f of x equal to 1 minus cos x over all x squared, and we want to know if what would be the limit of x approaches 0 for the function. All right, now be careful with this. You get tempted to just plug in the 0 for x and then go through, but you notice that x is in the denominator that is undefined, and that is basically a rational function. You can call it that, and we have to be very careful with whenever we are dealing with rational functions or functions that they may have discontinuity or asymptotes, and we have to really pay attention to how the function behaves. Now, one way is to graph this, and that's very simple. You use Desmos, and if you want to use Desmos, that's okay, or any other graphing tools, and then look at the graph, and then you can make the conclusion by looking at the graph and analyzing the graph. But algebraically may be also easier at times, because we can just simply plug numbers in and see what happens. First of all, we can't really simplify this function anymore in terms of the values. Remember that sometimes rational functions we can simplify, we can divide common factors, but here we can't. But what we can do, we can start putting some values in. It says x approaches 0, so let's start up with x equal to 1, and then we're gonna drop the value of 1 all the way to as close as we can get to 0. In this case, I stopped at 0.01, but if you keep doing that, you plug in number 1 for x and then do the math, and then as you go through it, you get these values. So here are the values, and notice what is happening as we are decreasing the value of x. As x approaching 0 for the function, these values, they start at 0.459698, which is right here. Then slowly they become bigger and bigger, but look at the limiting number. Now you can actually add another 0.001, and you notice that there will be more 9s past 4, and there will be like 4 more decimal places that added to the value by 9. That means very close to, approximately very close to 0.5 it will become. So now we can see, and you can actually do more if you want to do this. By all means do that, and you notice that even is closer to 0.5 by probably 17-20 decimal places, but it's still not quite 0.5. So what we can say is that the limit of the function as x approaches 0 here, so the limit as x approaches 0 for the function will appear to be 0.5. Okay, so this is a numerical way that we can actually use a table of values to come up with the limit.